This hearing will come to order. Good morning. I'd like to welcome our witnesses to today's hearing and thank you for your participation. Today the subcommittee continues our oversight of NASA's major programs by focusing on aeronautics. It's important that we do so because in many ways NASA's aeronautics program is one important answer to the question of what it is that makes NASA relevant to the nation's needs. At the same time, it has become painfully clear that NASA's aeronautics program has been significantly shortchanged in recent years when it comes to getting the resources required to address those national needs. That's unacceptable as far as I'm concerned. NASA has many worthwhile programs underway, activities that certainly deserve our support. Yet I'm hard-pressed to think of any program at NASA, with the possible exception of NASA's climate research initiatives, that is more relevant to our society's needs than NASA's aeronautics program. Aviation knits our country together, maintains our economic vitality, improves the quality of our lives, and helps enhance our national security. Moreover, aviation is a sector that makes a significant positive contribution to our balance of trade and promotes America's competitiveness in the global economy. Yet the explosive growth of aviation over the last several decades has brought its own set of challenges. These include dealing with the increasing congestion of the nation's airspace system, the need to maintain safety in the face of increasing travel demand, and the need to mitigate the negative impacts of aviation on the environment, whether noise, increasing energy consumption, or harmful emissions. Now, with respect to emissions, it's clear that an emerging focus of concern is greenhouse gas emissions that can contribute to the climate change, an area that this committee has been trying to call attention to over the past year. It is clear that meeting all of those challenges is going to require a national commitment to cutting-edge research into new technologies and operational procedures. We must focus on research that will ensure that the nation's air traffic management system will be able to meet anticipated demand while preserving safety and making the whole experience a lot more pleasant than it is now for the average traveler. We also need to focus on developing technologies that can make aircraft much more energy efficient and produce lower levels of harmful emissions. In addition, NASA needs to continue to pursue research that will open up new flight regimes for our utilization. For example, research that will enable such things as civil rotorcraft and supersonic aircraft that are environmentally friendly, safe, and that can operate without adverse impacts on our communities. We need to focus on research that will ensure that we maintain the high level of safety that we've enjoyed in our aviation sector. Indeed, the National Academies completed a decadal survey of civil aeronautics several years ago that identified some 51 key technical challenges around which NASA, in close collaboration with industry and academia, could structure a compelling and productive aeronautics R&D agenda for the next decade. That's the good news. However, as a number of the witnesses at today's hearing will testify, and as past witnesses have also testified, the decline in NASA's aeronautics funding is making it increasingly difficult to maintain an aeronautics research program that will be capable of stepping up to the challenges the nation's aviation sector will be facing in the coming decades. In short, the future relevance of NASA's aeronautics program is at risk just when the need for NASA's research contributions is greatest. In part, that is because carrying research to a level of maturity that allows the results to be transitioned to the users, whether in the public or the private sector, requires a greater level of investment than the current administration has been willing to make. That needs to change. If promising technologies and operational concepts aren't mature to the point that they can be transitioned to the users for future development or implementation, the nation will never receive the full benefit of the investment that is made in that research. That's the challenge we face. Aeronautics needs to be a priority at NASA. It's as simple as that. I think the NASA Reauthorization Act of 2005 got it right when it reaffirmed that, quote, aeronautics research remains a core mission of NASA. Our witnesses today will tell us about the ways that NASA research can contribute to a bright and exciting future for American aviation. We need to ensure that NASA maintains its commitment to carrying out that research. And we have a lot to discuss at today's hearing, so at this point I will again thank our witnesses for your participation, and we very much look forward to your testimony. And it's with a great pleasure I now recognize the ranking member, my partner, Mr. Feeney, for an opening statement.
Thank you, Chairman Udall, for calling today's hearing, and thanks also to our witnesses for taking time away from their busy schedules to come before us today. I realize most of you have traveled some distance, carving at least a day, if not two, out of your week to be here with us, and I appreciate that. Your wisdom and expertise are greatly appreciated. Mr. Chairman, there are very few enterprises over the past 100 years that have contributed so powerfully to America's economy and enhanced our nation's quality of life and our security than NASA's Aeronautics Research and Development Program. It actually began some 93 years ago with the establishment of the National Advisory Committee for Aeronautics in 1915. Even though the Wright brothers had conducted their first powered flight in 1903, in the beginning of World War I, the U.S. lagged behind Europe in airplane technology. In order to catch up, Congress founded NACA. NACA evolved into a splendid organization that produced gems of aeronautical research. In 1958, NACA was folded into NASA when the latter was created in response to the Sputnik mission. Exemplary aeronautical research continued, and the Space Task Force, which drew from the talented base at NACA's Langley Memorial Aeronautical Laboratory, began Americans' human spaceflight program, Project Mercury. The discoveries and applications that have flowed from NACA and NASA have spurred a large and vibrant aerospace industry. As should be expected, this industry in aerospace technology has evolved over time, especially over the last 3 decades. Since the late 70s, the airline industry has been deregulated. Manufacturers and carriers have been consolidated. The airspace has become saturated. Building new runways and airports has become very difficult and very expensive. The size and performance of aircraft operating the system are much more diverse, and environmental performance and efficiency are driving designs of the next generation of aircraft. The list of changes goes on. In the face of these changes, it's fair to ask how healthy and relevant is NASA's aeronautics program today? Is it appropriate for the federal government to continue to fund aeronautics research, and if so, where should the line be drawn between government and industry research responsibilities? Are NASA's aeronautics researchers pursuing the right questions? Is the agency making the most effective use of research funding? Are the agency's discoveries and products being adopted by industry? Adding further complexity to the discussion is the Nextgen program, of which NASA is a critical partner. Unlike the mixed results from past efforts to modernize the air traffic control system, Nextgen must succeed. There's no alternative. In the increasingly competitive global economy, America's advantages in mobility and logistics cannot be frittered away. And in an era of increased emphasis on energy and environmental concerns, I gently point out that Nextgen's efficiencies will produce energy savings and a lessened environmental footprint as aircraft use more direct routes, experience less air and ground holds, and employ techniques like continuous descent approach. Improved mobility is environmentally friendly and economically beneficial. But if Nextgen is to succeed, NASA must develop and validate technologies to enable more efficient, environmentally benign, and safer aircraft and engines, as well as surveillance, navigation, and control infrastructure. I'm hoping the testimony we'll receive this morning will help us reach a broad consensus on how to shape the program to meet current and future challenges. I'm especially anxious to hear the views of industry and from the National Research Council about their findings and recommendations contained in their recently published analysis of NASA's aeronautics programs. I also want to congratulate Dr. Shin, a longtime NASA aeronautics researcher who was recently appointed to head the agency's Aeronautics Directorate. Aeronautics is not a mature industry. Any number of new technologies that enable cleaner, quieter, more efficient aircraft will make a telling difference between success and failure. We cannot afford to cede our leadership to foreign suppliers. With that, Mr. Chairman, again, thank you for the hearing, and I look forward to hearing from our witnesses.
Thank you, Mr. Feeney. I'd like to move right to an introduction of our panel of witnesses. First up, we have Dr. Jaiwon Shin, who's the new Associate Administrator at NASA for the Aeronautics Research Mission Directorate. Congratulations on your new appointment. Next to Dr. Shin, we have Mr. Carl Meade, who's appearing today as the co-chair of the National Research Council's Committee for the Assessment of NASA's Aeronautics Research Program. Welcome to you. Mr. Preston Henne is the Senior Vice President for Programs, Engineering, and Testing for Gulfstream Aerospace Corporation. We're looking forward to your testimony. There's some exciting things going on at Gulfstream. And then finally, we have Dr. Ilan Kroo, who's a professor in the Department of Aeronautics and Astronautics at Stanford University. Welcome. I think you all know that spoken testimony is limited to 5 minutes each, after which members of the subcommittee will have 5 minutes each to ask questions. Dr. Shin, we'll start with you. If you would turn on your microphone, please.
All right. Chairman Udall, Ranking Member Henne, thank you for this opportunity to appear before you today to provide an update on NASA's Aeronautics Research Program. I'll also address the issues raised by the subcommittee concerning the R&D challenges in aeronautics, specifically the Next Generation Air Transportation System, Nextgen, aviation safety, aviation environmental impacts, and promising new flight regimes. As you know, NASA has a long and successful history of conducting R&D in technologies that have benefited our nation's aviation community. One such example is the vertical extensions found on wingtips, which help to improve an aircraft fuel efficiency and cruising range, known as winglets.
Dr. Shin, would you pull the mic a little closer? We just want to make sure we get your words in the record. Thank you.
Known as winglets, this technology was developed by NASA during the 1970s and is now found on aircraft of all types around the world. You should have before you a photo that depicts some examples of NASA innovation that have made a difference in the way we safely travel today. NASA's Aeronautics Research Mission Directorate, or ARMD, continues this tradition through its commitment to conducting long-term, cutting-edge research for the benefit of the broad aeronautics community and in support of NASA's goals for both manned and robotic space exploration. I believe that aviation in the United States could be on the verge of another renaissance. Demand for air travel is expected to double or even triple in the next 2 decades, which will require a revolutionary air transportation system. In order to realize this new system, a number of significant challenges must be overcome, such as protecting the environment, ensuring safety, dramatically improving efficiency, and revolutionizing the ways we manage the flow of aircraft. The aeronautics research that we conduct today will play a vital role in transforming the air transportation system of tomorrow. While each of the 4 programs within ARMD uniquely address critical challenges, the 4 programs integrate their research for a holistic approach to high-level challenges such as Nextgen. I would like to illustrate why this holistic approach is important by going over the 4 questions raised by the committee. As for the Nextgen R&D issues, I must say that it is difficult to identify the most critical barrier to Nextgen. While it is easy to consider the air traffic management system be the most critical issue, the reality is we must treat the entire system as an interrelated enterprise instead of segregating research into separate areas. To foster this thinking, ARMD's research programs address issues of air traffic management, avionics, advanced vehicles, safety, and environmental impact. The vast majority of what ARMD does is directly aligned with the Nextgen vision that is clearly supported by National Aeronautics R&D policy. It is a well-known fact that the current U.S. air transportation system is among the safest modes of transportation ever. Even as we dramatically transform our air transportation system, it is imperative that we maintain or preferably improve on this impressive safety record. ARMD's aviation safety program is working on development of new technologies, such as new airborne sensors of flight hazard, method of controlling aircraft even in upset conditions, and systems capable of monitoring aircraft and airspace to detect anomalies before they can develop into accidents. Likewise, the aviation safety program is developing new materials and structure that can age with great durability and less fatigue, and is establishing a research program in human system integration in next-gen operations. I should point out that as the number of flight operations at many of the largest airports in the nation continues to grow, environmental concerns over noise and emissions will limit the capacity of those airports and therefore limit the capacity of the entire system. NASA's Fundamental Aeronautics program is working to improve the environmental impact of aviation through green aircraft research initiatives to reduce noise, local and global emissions, and local air quality. We are also working on advanced vehicle concepts that will satisfy both forecasted demand and environmental compliance. Furthermore, the Aviation Systems program is ensuring that today's fleet and new generations of vehicles can operate within the Nextgen in a manner minimizing aviation's environmental impact. NASA is not fixated on the developing new capabilities in just one flight regime, and I believe that an ideal situation will exist when multiple vehicle types exist, each suited for a particular use, operating in an air transportation system that is flexible enough to accommodate a wide range of vehicles without limiting performance. Examples of some of the most promising concepts include advanced subsonic transonic transports with nearly half the fuel burn of today's vehicles and a noise footprint that can be confined to the boundary of the airport. Advanced supersonic transports with low sonic boom characteristics so that the aircraft may be flown to supersonically over land. And advanced rotorcraft that allow vertical or short takeoff and landing with vastly improved range and performance and reduced environmental impact, mainly from noise. I am pleased to report to you that NASA Aeronautics now is in full execution of a robust fundamental research program that is well aligned with the National Aeronautics R&D policy and directly supports the development of next-gen system. ARMD's commitment to technical excellence with strong partnerships with industry, academia, and other government agencies will ensure our reputation as the world's premier aeronautics R&D organization. I welcome any questions you may have. Thank you.
Thank you, Dr. Shin. Mr. Meade.
Mr. Chairman, members of the subcommittee, thank you for inviting me here to testify today. My colleague, Dr. Donald Richardson, and I are co-chairs of the National Research Council's Committee for the Assessment of NASA's Aeronautics Research Program. It is in that capacity that I appear to you today. Unless otherwise noted, the views I offer are strictly those of the committee and not those of my employer, Northrop Grumman Corporation. In addition to responding to the questions posed by the subcommittee in its April 17th invitation to appear, which will be annotated in my written testimony, I'd like to make some general observations. Our committee evaluated NASA's entire aeronautics portfolio, both civil and non-civil. However, the majority of our attention was devoted to the request by Congress to assess NASA's aeronautics research program against a very specific benchmark. That was the Decadal Survey of Civil Aeronautics, published by the NRC in 2006. Therefore, most of our findings and recommendations are centered around that comparison. The NASA Aeronautics Research Program does have room for improvement, both in its direction and its execution. When assessing NASA's research against the recommendations of the Decadal Survey, we found mixed results. Our study found that NASA's efforts to achieve 20 of the 51 Decadal Survey technologies have no significant shortcomings or very minor shortcomings that are recoverable within the overall project concept and will substantially advance the state of the art. 7 of the 51 have major shortcomings that would be difficult to recover within the current overall project concept. For the remaining 24 challenges, NASA is effectively addressing some areas, but not others, and so the results can best be described as mixed. Your subcommittee specifically requested information regarding safety and environmental challenges. I'll try to summarize those right now. Of the 20 challenges identified with little or no shortcomings, about half are related to safety or the environment. The same can be said for the other categories I just outlined. And this is consistent with the safety and environmental content of the entire set of 51 technology challenges, which is about half related to safety and the environment. It would be easy to misinterpret our findings as largely negative. This is not the intent of the committee, nor would it be proper interpretation. To regard the results of our study as an indictment of the performance of NASA's Aeronautic Research Mission Directorate, our committee would like to emphasize that by and large, we found the AR&D workforce to be both dedicated and competent. Having said that, it does not appear that the AR&D has responded in any significant way to the recommendations of the Decadal Survey. Keep in mind, however, that the Decadal Survey of Civil Aeronautics was the first survey of its kind published in aeronautics. Consequently, AR&D has no experience in utilizing decadal surveys, which may help explain why the Directorate did not respond immediately to its publication. To properly understand our report, it's also important to keep in mind that the authors of the decadal survey itself were not bound by budgetary considerations. And this is unlike decadal surveys from other scientific disciplines which we have seen in the recent past. Therefore, it is not unexpected that AR&D would not be able to make progress on all 51 of the technology challenges contained in the decadal survey. In fact, barring an increase in funding for this activity, we have recommended that AR&D redefine its scope and address only the challenges with the highest priorities where significant, timely progress can be made in advancing the state of the art. Aside from the quality of the research conducted by AR&D, we would stress the need for a cultural change within the Directorate. Indeed, the committee was most concerned about the lack of urgency demonstrated by some projects and the tendency of some researchers to assume that the ultimate consumer of the fruits of their labor was NASA itself. As one example, one of AR&D's 3 operating principles states, and I quote, "We will focus our research in areas that are appropriate to NASA's unique capabilities," close quote. In my opinion, NASA and the country would be better served if the principle were revised to include, quote, "We will mold NASA's unique capabilities to enable research in the most vital areas." I'll be glad to answer any questions you may have.
Thank you, Mr. Meade. Mr. Henne.
Mr. Chairman, members of the subcommittee, thank you for this opportunity to testify before your committee. My employer, Gulfstream Aerospace, is headquartered in Savannah, Georgia, with some 9,800 employees. Gulfstream is a $5 billion annual revenue company that designs, builds, and services premium business aircraft. We have major facilities in 8 states within our continental borders. Gulfstream is a current product line of 7 different models, ranging in price from $14 million to $59 million. Our primary competitors are Canadian with Bombardier, French with Dassault, and Brazilian with Embraer. Foreign countries and businesses recognize the huge value associated with strong aeronautics enterprise. You have already, both the members have identified the value of aeronautics today, and I won't delve into that. But foreign countries represent and invest in national aeronautics enterprises. The U.S. seems to take aeronautics for granted, often describing it in political circles as a mature industry able to fend for itself in terms of continuing R&D needs. I suspect, however, that we should not be ready to close the Aeronautical Patent Office. To give one grand example, successful civil supersonic transportation is still to be achieved. Yet we continually see decreasing NASA Aeronautics R&D budgets. Over the past 10 years, funding in NASA aeronautics research has declined by some 48%, from over $1 billion to somewhere around $622 million today. The U.S. is down to 1 civil aircraft manufacturer and doesn't even participate in the regional jet manufacturing market. Gulfstream used to be alone in the large cabin business jets. We now have 3 strong foreign competitors intent on capturing our market. More importantly, they are keen on capturing the engine for jobs and economic growth. Why is it important for the federal government to invest in aeronautical R&D? The aeronautics enterprise contribution to jobs, to tax revenues, to favorable balance of trade, as you, Mr. Chairman, have already mentioned, is massive. The recent executive order establishing a national aeronautics R&D policy states continued progress in aeronautics, the science of flight, is essential to America's economic success. Congress in 1958 directed that government-sponsored aeronautical activities be conducted to contribute materially to specific objectives, including the following: improvement of the usefulness, performance, speed, safety, and efficiency of aeronautical vehicles, and the preservation of the role of the United States as a leader in aeronautical technology. The role of federal investment in aeronautics is to advance U.S. technological leadership, to lead innovation, and to develop advanced aeronautics concepts and technologies. It is the catalyst for progress. In the past, NASA Aeronautics has served as a great source of aeronautical R&D efforts. Dr. Shin mentioned some of those. However, the ever-decreasing budgets, this pipeline is drying up. In recent years, even vehicle technology demonstrations, a vital risk reduction link between basic R&D and product application, have been terminated. This has been a substantial blow to maturing aeronautical technologies and for U.S. companies involved. Clearly, our aeronautics program needs a revitalization effort to address existing priorities and to address the insufficient aeronautics research funding. How do we ensure that it's relevant? The following considerations are put forth. An understanding that the status quo with ever-reducing budgets isn't working. NASA Aeronautics needs to work beyond just fundamentals and take a continuing role in technology demonstration. And the split, the public-private funding participation needs to be more balanced in an equitable situation. According to a recent article in well-respected trade publication, government versus private expenditures for all U.S. R&D have virtually reversed themselves in the last 45 years. In '64, the government funded 64% of all R&D. In 2006, industry funded 66%, or roughly $220 billion in R&D funding. Specifically, NASA's aeronautics budget should be increased to fund research into Nextgen. We've already heard that. In environmental research, we've heard that. In aviation safety, NASA clearly plays an important role in all of those areas. In opening new flight regimes, NASA should be leading the way. Frankly, what more important leadership role can NASA Aeronautics have? As mentioned earlier, we have yet to achieve successful supersonic civil transportation. To achieve that really requires improvements in aeronautical technology, technology demonstrations. This is what NASA Aeronautics has historically excelled in and should continue to excel in. Risk reduction and barrier removal in R&D focused on new flight regimes is a strong inducement for commercial growth, jobs creation, and protecting the national aeronautics leadership position. In closing, my recommendations are that the budget for NASA Aeronautics must increase substantially. The reestablishment of NASA Aeronautics as a vital R&D activity, a high priority activity, supporting a broad group of U.S. Companies needs to happen. NASA Aeronautics procurement policies need to allow commercial contracting practices. The U.S. government action to minimize foreign competitor advantages due to strong financial aid needs to occur. And separation of aeronautics activity out of the Space Agency as a means to implement a strong aeronautics R&D policy needs to be considered. Mr. Chairman, thank you for the opportunity to express these views, and I look forward to your questions.
Thank you, Mr. Henne. Dr. Kroo.
Okay, thank you, Mr. Chairman and members of the committee. Thank you for the opportunity to testify on NASA's Aeronautics Research Program. I teach at Stanford University and conduct research related to future aeronautical concepts. My familiarity with NASA's research program comes from continuing interactions during my career at Stanford and participation in several studies by the National Research Council, including the decadal study of civil aeronautics in 2006. I'll focus my comments on three questions suggested by the committee. The first question was, what are the most important challenges to be addressed if the nation is to sustain an efficient, environmentally compatible, and safe aviation system, and what should NASA's role be in addressing these challenges? Well, as noted by my colleagues and the chair, the nation's air transportation system has been a critical engine for our economy and quality of life for many decades. Commercial aircraft have made dramatic improvements in cost, safety, and efficiency over the last 50 years. However, the growing global demand for air travel and the impact of this growth on the environment have led us to a critical point in the evolution of aviation. Even today, system capacity limitations, the cost of fuel, and local environmental impact are clear problems. It will certainly not be possible to sustain an acceptable system in the future without significant technical advances. The greatest challenge will be to accommodate the anticipated growth in air travel without increasingly problematic global and local environmental impact. This is not just a regulatory problem. It requires long-term research and development of new technologies spanning multiple disciplines. In many ways, NASA is ideally positioned to address these problems. No other agency or industry has the experience and tools to both study the impact of aviation on the global environment and to develop technologies that may be needed in the future aircraft engines, airframes, and air traffic management systems. Unfortunately, the magnitude of the problem is great and growing, and NASA's aeronautics program is not. This brings us to the second question. The adverse impact of aviation on the environment has long been a concern, and that concern has recently expanded to include the impact of aviation on climate. What are the most promising R&D avenues for addressing these concerns, and what should NASA's R&D priorities be in this area? Well, in terms of efficiency and environmental impact, commercial aviation can be considered a real success story. A few decades ago, fuel usage per passenger mile was about 70% greater than it is today. A flight across the country in a new 737 now requires only about 29 gallons of gasoline or of kerosene per person. That's about 80 passenger miles per gallon. Unfortunately, the trouble is that trillions of passenger miles are flown each year, and that traffic is expected to double over the next 20 years. So although aviation currently accounts for 2 to 4% of human CO2 emissions, its impact on the environment may be much greater in the future due to this projected growth, pollutants other than CO2, and the disproportionate effect of emissions at high altitudes. Local and regional environmental effects such as airport community noise and local air quality will also be aggravated by the projected increase in air travel. So in order to achieve a sustainable aviation system while accommodating increasing demand, dramatic improvements in aircraft efficiency are required. Unfortunately, most of the easy steps have already been taken, and further advances require research into better modeling and design capabilities, new configuration concepts, improved flight management systems, and alternative fuels that are well suited to aviation use. Many uncertainties also remain in the effects of aviation on the atmosphere, and research is also required to determine just how to minimize the impact of air travel in the future. Specific, aggressive, but rational targets for aircraft noise and emissions should guide the research priorities for NASA. Goals such as those described in the National Plan for Aeronautics R&D, published last December, are clearly affecting NASA's research plans, but cutting fuel consumption and noise by 50% is very difficult, and it is not clear that this can be achieved with the agency's current resources. So what does NASA need to do so that its aeronautics R&D activities can be effectively transitioned to the public sector? Well, in the past few years, NASA's done a good job in defining a strong fundamental research program within severely limiting budget constraints. It has focused R&D activities on the kind of fundamental research that will be important for longer-term solutions. But if the goal is to actually create a future system that will work, not just write great research papers, much more is needed. The next step is to understand how some of the most promising technologies can be integrated at the system level and transitioned from the lab to the user. These critical integration and validation projects will require close collaboration with industry, but it is difficult to see how they can be undertaken with NASA's current level of investment in aeronautics. Again, thank you, Mr. Chairman, for the opportunity to testify. I'll be happy to answer questions.
Thank you, Dr. Kroo. At this point, we want to move right to our first round of questions. I'm going to recognize myself for 5 minutes, and I want to turn back to our final witness, Dr. Kroo. Each of you, with the exception of Dr. Shin, who's being a loyal representative of the administration, has highlighted the negative impacts of the declining NASA aeronautics budget. If NASA's aeronautics program were to be given a higher level of funding on a sustained basis, not just a one-year infusion of cash, but on a higher baseline funding level by this Congress or the next administration, what would be the most productive uses for that additional funding? What do you consider to be the most important priorities to pursue? Maybe we can move from my right to my left. Starting with Dr. Kroo.
Well, as I mentioned, I believe that the issue of future technologies for reducing environmental impact are some of the most important areas for NASA to be working on. And if given a larger budget, NASA needs to proceed from the kind of fundamental research that they're doing very well to more research that can be used by the industry to actually achieve some of the goals that have been stated. So progressing from fundamental research to integration, system-level research, and validation experiments and research work is a critical aspect of that.
Move to Mr. Henne. You've advocated what, an $80 million or so increase over last year's approved level. What critical research projects would you target with that increase? You have to turn your microphone on if you would.
Sorry.
No.
I think you have some goals of the country with the environmental impact, with Nextgen, with safety. And frankly, those should be the outcomes. What needs to happen is an investment in advanced technology and advanced concepts. It's with the vehicles you're going to achieve the improvements in the environment, the improvements in safety, the improvements in the ATC operation. It has to come from the vehicles. And so my look at that would be we need to do more in advanced concepts and vehicle technology.
Mr. Meade, would you care to comment?
Yes, Mr. Chairman. Our committee was asked to specifically concentrate on the decadal survey. So with respect to that framework, I would like to answer that. I think if you read our report, what you'll find is that concentration on fuel efficiencies and next-gen enablers would be at the top of the list, in addition to all of the safety efforts within the decadal survey, the 51 challenges. And those safety efforts come down to basically collision avoidance, wake turbulence, and weather avoidance.
Dr. Shin.
Well, I couldn't agree more with other witnesses' areas that they're pointing out. As the current NASA program clearly indicates, that we do address those air traffic management, safety, and environmental impact area within the budget that allocated by the President.
Let me move to Nextgen, if I might, and I'm not going to get all of these questions tied to Nextgen in, but we will have a couple of rounds. Dr. Shin, speaking of Nextgen, are you satisfied that the connection between the Aeronautics R&D and the JPDO's research and development plan, integrated work plan, is clear enough? And is it a level of detail that allows NASA researchers to establish work priorities that will result in the timely delivery of Nextgen's capabilities?
I believe the JPDO has evolved significantly, both in terms of scope and quality of the documents they have been generating. And in particular, last year, I believe all the member agencies worked very closely along with JPDO to generate several seminal planning documents. Because the nature of the work that JPDO is trying to embark and coordinate, it is a daunting task, trying to revolutionize the nation's air transportation system, not just from air traffic management perspective, but as I mentioned in my oral testimony, as a whole system. It is expected that such documents will take some time to have a necessary depth and accuracy and clarity. So I think JPDO has been working diligently on that, and NASA is heavily and very proactively participating in the development of all those documents.
Thank you, Dr. Shamon. I'm going to return to this in the next round of questions, but at this point I'd like to recognize the ranking member, Mr. Feeney, for 5 minutes.
Thank you, Mr. Chairman. I also was interested in the progress of Nextgen. Mr. Meade, with respect to the 7 areas where you discovered major deficiencies and the other 24 that have problems, which of those areas do you think are most critical that NASA can address within current budget, and which do you think cannot be addressed with reform or changes without additional funding? Can you just identify some of the major ones? You said priority would be Nextgen and safety and environment, but can you be more specific?
I could if I could refer to the study itself, which was, there were 51 of those.
Got a complicated color chart here.
There you go. Yeah, as you might imagine, it was fairly complicated. Now, I'd like to talk a little bit about the 7 that we found major deficiencies. 4 of those 7, NASA was not working on at all. I mean, those were simply omitted from the portfolio of research for various reasons. Probably low priority or lack of staff or whatever. So that was that was applied to 4 of them. The other 3,
for example, unmanned aerial vehicles.
That's right. For example, and you know, we could turn to that color chart that you have and see which ones are actually not worked on. There were 3 others that were poorly managed, probably best described as not advancing the state of the art for various reasons. And so we would recommend that those things with the current budget scenario be totally dropped or revamped. And to get to the basis of your question, though, Mr. Finney, I don't think that we're in a position right now to tell you that this is the top priority and this is the second priority. As you know, the decadal survey itself refused to do that and listed the top 51 that they thought was the most important. I think what we would recommend as a committee, however, is that a priority scheme be established and have NASA itself go in and decide which is the most important ones to work on.
Well, they sort of do that every year when they propose their budget, I assume.
They do, but so far we have not seen any evidence that they use the decadal survey as any sort of guiding light.
Mr. Meade, one of the recommendations was that NASA, and I quote, not necessarily include the immediate public dissemination of results to potential foreign competitors. Mr. Henne, listed 3 of his. I suspect there'll be more in the future. Why did your group feel compelled to make this recommendation? Is it consistent with the practices of other Western governments when they do research and development? And then maybe we'll hear from Mr. Henne, and he may have an opinion on that as well.
I think that comment was, the genesis of that comment began to build in our committee from looking back in the last 50 years of aviation history, particularly on the 1958 law that brought NASA into existence, where, as a matter of fact, Mr. Henne in his testimony quoted that one of the purposes of NASA was to make sure that America stayed in the forefront of aviation. Back then, there were natural inhibitors to the dissemination of information outside our borders. And the feeling of the committee was that this
American cars and airplanes used to be made entirely in America back then, too. That's
used to be, right. And so we had a very large capability to absorb the fruits of the labor of all this research ahead of any competition. Well, Tom Friedman was right. The world is flat. And by the way, there are many competitors around the globe now that have can very quickly react to the results of that research. And so we have to decide if the American public is paying for this very worthy research, that the American public gain the benefit of this research.
Well, real quickly, you made a recommendation. If they find some quantum leap in capabilities, should they provide it to Mr. Henne's company that would affect, for example, just the niche that Mr. Henne's in? Should they provide it to Mr. Henne's company but no foreign companies?
I think that's beyond the scope of what our committee would recommend. However, this is a competitive atmosphere that everybody operates in.
Mr. Henne, do you have an opinion about that?
That's a difficult question. In terms of transfer of information, you certainly would like to think that information that is generated by research funded by the U.S. public advantages U.S. interests first. I mean, that would be a guiding principle. But in today's global environment where we have suppliers that are international, we deal with international sales, that dividing line gets pretty hard to define in reality. And so you would like policies that advantage U.S. interests. If it becomes crippling, then it doesn't do anybody any good.
I'll have some more questions if we get to a second round. Thank you, Mr. Chairman.
The chair recognizes the chairman of the Subcommittee on Technology and Innovation, the member from Oregon, Mr. Wu.
Thank you very much, Mr. Chairman. Dr. Kroo, your testimony had some interesting comments about environmental effects of aviation, and I wanted to focus on a particular environmental effect which was not addressed in your testimony, and that is noise pollution. There was an interesting article in Aviation Week this week about helicopter rotor blades which make less noise. When I was either a freshman or sophomore, we no longer have the benefit of Mr. Weiner on this committee, but he would ask very pointed questions about the next generation of jet engine technology that would be more quiet. It is my impression that whether it's from a research or more likely from a regulatory point of view, the Europeans have taken the lead in quieter engines. Are we putting enough research emphasis on noise pollution in your view, and can you discuss that for us just a little bit?
Sure. There are two kinds of goals. One that may be addressed with regulatory issues, which are near-term goals, and then there are the goals that apply over a longer term over the next couple of decades. Certainly some of the near-term goals can be addressed with regulation and in next-generation designs of airplanes, but in the future, rather dramatic changes in noise of aircraft are possible and are consistent with some of the other environmental goals. So that as airplanes become more efficient, they don't just require more acoustic treatment on engines, but the engines can actually be smaller. They can have less jet noise on takeoff, and therefore airplanes designed with the environmental impact in mind can really be dramatically quieter.
That's 20, 30 years out.
So the goal of the European research frameworks is to achieve half the noise by 2020, half the average noise. This is not inconsistent with some of the R&D aeronautics goals that have been provided quite recently in this country. That would make a dramatic difference. Having a lot more traffic will also make a dramatic difference, and we have to figure out how to accommodate that.
Right. Cutting the noise in half dramatically changes the noise footprint on the ground. Let me ask you a question about the research infrastructure. One of your colleagues at Stanford was very, very concerned a few years ago, I believe, about the number of wind tunnels available for research here in the United States. In your view, has that situation gotten better or worse?
That situation is somewhat better. The Air Force, for example, has stepped up to fund some of the facilities in this country, such as the National Full-Scale Facility, the 80 by 120-foot wind tunnel located at NASA Ames. There are many wind tunnels that are continually closing down, being refurbished only not to be used in this country, And this is a difficult situation. We still go to Europe to do high Reynolds number wind tunnel testing, and that's a problem.
Well, Dr. Kroo or Mr. Henne, do you see going to Europe to use their wind tunnels as a problem?
Let me, that's a fascinating question for me, because we just completed a whole series of development wind tunnel tests on a new aircraft model, the last one being the most important, most expensive, and it was done in Europe.
Do you see that as a problem?
Yes, it is, because you have to believe, you have to walk out of that tunnel believing that your data is available to others.
Dr. Kroo, would you agree with that assessment?
I think so. I do think that some of the facilities really are very good in Europe, and we should take advantage of it, but it is indeed always a question. I have to say, with respect to keeping some of that data in the U.S., and with respect to the previous member's question, it is a difficult question. One has to walk that line between
Dr. Kroo, I don't mean to cut you off.
No,
I'm going
fine.
to. Mr.
Yes,
Shin, Dr. Shin, how did NASA let the situation develop where Mr. Henne's data is going to be used by folks who didn't pay for it?
To that very specific issue, NASA Aeronautics has established the program called Aeronautics Test Program 2 years ago. And now,
but it doesn't seem to be working.
Well, in the past, there has been some issues with the maintaining and upkeeping the NASA wind tunnels. So that's why we established this program, and we are making good progress. And we are also working with our partners in DoD.
So, Dr. Shin, if we hold this hearing again in 2 years or in 1 year, will you have a different answer for Mr. Henne? Will you have a solution for Mr. Henne?
We are certainly working toward that goal.
Are you working toward it, or will you have a solution for Mr. Henne?
We'll do our best.
Thank you.
Mr. Congressman, I wonder if I could make a shot at the first question you asked, and that was about investment in noise. I don't believe that we, the U.S., are investing enough in it, and I brought 2 exhibits if you're interested. One is the CLEAN program, as provided, some information provided both by the FAA and NASA. And if you read it, it's a program proposed to spend up to $20 million a year for 4 or 5 years. Up to $20 million a year for 4 or 5 years. This is at the same time that the announced program by the European Commission is 1.6 billion euro for 7 years, which means $2.4 billion on the same subject. And so it's an order of magnitude larger investment in clean technology that is being made in Europe compared to the U.S. An order of magnitude.
Well, I thank you for calling that to our attention and yield back, Mr. Chairman.
Thank you. We'll start another round. The chair recognizes himself for 5 minutes. I want to pick back up on Nextgen and Mr. Meade. In the area of advanced communication, navigation, and surveillance technology, your committee found that NASA's air portal and aerospace efforts didn't have planned research to address the R&D milestones. Since the Nextgen concept seems to rely extensively on those capabilities,
if I heard your question correctly, Mr. Chairman, I think we should be concerned. We evaluated the milestones against what we thought would be a rational program and found deficiencies in those sensor areas. And so Nextgen depends upon those sensors and the integration of those sensors within the airspace systems. And I would say that that would be a high priority item.
Anybody else care to comment? Let me move to Mr. Henne then. In your testimony, you state that NASA Aeronautics needs to work beyond just fundamentals and needs to take a continuing role in technology demonstration. And then Dr. Kroo, you stated in your testimony that NASA's focused R&D activities on the kind of fundamental research that will be important for longer-term solutions. The next step is to understand how some of the most promising technologies can be integrated at the system level and transition from the lab to the user. It seems to me that both of you are saying that NASA needs to do more than fundamental or basic research if it's to be relevant to the nation's needs. Is that correct?
That's correct. Those two statements are very similar in reality. One of the things that seems to have dried up is large-scale demonstrations of technology. Those are the things that reduce the risk, that give companies confidence, in fact, that the technology is mature enough to take to market. And when that link is dropped because it's expensive, it costs a lot to do those kind of demonstrations. When that's dropped, you've broken the chain. The technology isn't going to advance. It's going to stay in the lab. It's going to stay in the office, and it'll be a small-scale study going on and on and on. And progressing it to the market won't happen.
Dr. Kroo, I see you nodding. Would you have any examples as well of opportunities that might be missed?
Well, absolutely. And I think that it's often tempting to think of these as demonstrations, but in fact they're also experiments. These kind of system-level research activities let you know what you don't know, and that's very important in this area.
Mr. Meade, Dr. Shin, would you care to comment?
I fully support it. One of the ideas that we came up with on the committee was the fact that, or realizations I should say, was the fact that there are very few flight experiments any longer for a couple of reasons. Everybody's afraid of failure, and once you get in the air, there's always a chance, particularly as you're advancing the state of the art, that it won't work. And that somehow is a negative mark on somebody's career, and so, therefore there is a tendency to avoid those steps. And there's an intangible result from actually getting out into the field and flying something, and that is you invigorate an entire generation of people who would like to come study in the avionics field, or I should say aeronautics field. So there's a tremendous benefit in making that user connection and also energizing the system.
Dr. Shin would want to give you an opportunity to comment.
Yes, I do recognize that we do not have large-scale technology demonstration or validation effort as Henny pointed out. So that is an accurate statement. But I also like to submit that in current NASA aeronautics portfolio, we do sizable amount of flight experiments and working with industry. And so those are not in the traditional sense, large-scale, highly integrated flight validation effort, but we do work in, as an example, blended wing body flight experiments that we are still conducting, and also we, as a matter of fact, work with Gulfstream on the sonic boom mitigation technology. That was done through flight experiment as well. So again, within the budget that has been allocated to us, we do believe try to maintain the relevance with the industry and also conducting flight experiments.
I hear implied in your comments, though, if we were able to find more resources, there's certainly more that you could do in your directorate.
I think we are actually, NASA aeronautics and aeronautics community as a whole, in good situation actually compared to previous years, because we do have this National Aeronautics R&D policy and plan that will guide us, government agency like NASA, set the right priorities. So we will continue to work within that plan and policy and make sure that our program is well aligned.
Thank you, and the chair recognizes the ranking member, Mr. Feeney, for 5 minutes.
Thank you. Dr. Shin, the National Research Council's assessment of NASA's Aeronautics R&D recommended that, and I'll quote, "The Aeronautics Research Mission Directorate should ensure that its research program substantially advances the state of the art and makes a significant difference in a time frame of interest to users." They go on to recommend that NASA, in consultation with the aeronautics research community and others as appropriate, should redefine the scope and priorities within the aeronautics research program to be consistent with available resources. So they essentially suggest that there needs to be some fundamental redefinitions of priorities, and additionally, as Mr. Meade stated earlier, they suggest that there may be a cultural problem with respect to lack of urgency and a view towards who the end user is, as opposed to NASA using the technology, the end user. How do you respond to the National Research Council's assessment and Mr. Meade's suggestion?
I generally agree with the essence of the recommendation, which points out that NASA Aeronautics should be staying relevant in serving up the U.S. industry and U.S. aeronautics community. And for the past almost 19 years that I have been with NASA Aeronautics, I have always thought, and my colleagues have always worked to address U.S. aeronautics community requirements and needs. So if there are some pockets of areas or groups of researchers who feel that NASA Aeronautics is serving to our own need, that is something that I must correct, and that is not what NASA Aeronautics is all about. We don't produce our own aircraft, or we don't serve to our own outcome. So again, in general, I respect NRC's observation and recommendation. So if there are cases like that, we will certainly work to remedy that. In terms of staying relevant, we are making all efforts because we invite industry partners to our annual technical interchange meetings that all three research programs have. And so far we have had one or two such meetings since we restructured the aeronautics program. And I have gotten, and I have also participated in some of those meetings, have gotten a lot of healthy interactions. So tech transfer or knowledge transfer should happen at all levels. That's my belief, not just at the end of the rope when everything's culminated to some large-scale validation. So we have to work with industry partners and academia up front and all along the technology development. So we actually identify the transition point jointly, rather than NASA decides this is the point that we have to transfer the technology. So by doing some of these things and focusing on what we do best, NASA Aeronautics does best, I believe we can make still significant contributions in staying relevant to U.S. requirements and needs.
You just mentioned your academic partners. Dr. Kroo is here also. For example, adjacent to my district is Embry-Riddle University, has a keen interest in aeronautics. What can you describe NASA's cooperation and use of academic researchers? Because it appears to me that would be a place where cutting-edge, futuristic, research is the norm. And if you want to stay not just current, but ahead of the curve, academia seems to be an important part of that program.
I wholeheartedly agree with your view toward academia's role in our nation. And to that end, 2 years ago, we have set aside, not as an afterthought, but we set aside $50 million out of our annual budget to foster and promote and integrate these cutting-edge ideas and concepts coming from academia. And the funding vehicle is called NASA Research Announcement, in short, NRA. NRA is a very flexible procurement vehicle, so it doesn't only allow grants. It could be cooperative agreements or a contract even. The participants are not only universities, but the idea of NRA is exactly what Mr. Finney mentioned, to promote and bring out these cutting-edge ideas and concepts. And I'm happy to report for about a year and a half that we started doing this, we have received over 1,300 proposals, and we have awarded over 300 recipients through NRA process. And the market or the participants are growing and also spanning not just from academia and also industry. So today, again, I'm happy to report that we have about 30% industry participation and 70% university in terms of number of awards. but in terms of funding, 40% industry and 60% academia. So one of the gratifying things through NRA that I have observed is some of these small universities or universities that we never really thought traditionally that they would have aeronautics expertise. We are getting a lot of these non-traditional engineering powerhouses, if you will, and a lot of good ideas and concepts. So it's solely based on the quality of the proposal. And so we are making good progress, and I have been very pleased with the progress we've been making.
Thank the gentleman. I now would like to recognize one of the most active members of this subcommittee, the gentleman from New Jersey, Mr. Rothman.
Thank you. I want to thank our distinguished chairman and ranking member for holding this very important hearing and for your consistent and strong interest in these matters. And I apologize for being late, gentlemen. I had another place to be, but I'm very interested in this subject. Let me ask Mr. Meade. I have a few questions. I represent a densely populated region in the most densely populated state in the country. So aircraft noise and aircraft pollution are constant concerns for the quality of life of my constituents. I believe that aeronautics research and development, creating quieter, safer, cleaner aircraft, is an important aspect in dealing with the quality of life issues my constituents deal with on a daily basis. So, Mr. Meade, what can this committee do to help NASA achieve these important goals?
Well, I think as far as our committee from the NRC is concerned, we would recommend that the decadal survey be followed with regard to the environmental challenges that they have already specified. And so I think the best and shortest answer I can give you is take a look at the decadal survey and direct NASA to adjust their priorities to respond to those challenges.
Thank you. Dr. Shin, are you familiar with this survey that Mr. Meade has referred to?
I am.
And has NASA taken into account the conclusions of that survey in its budget, in its project proposals or plans for the coming year?
Yes, we have made a very thorough assessment from the survey, and in fact we submitted our report to Congress a year and a half ago, as I recall. But in the environment area, this is one area that NASA Aeronautics program actually has a very strong technology development effort.
Dr. Shin, would you pull the mic a little closer again?
Yes, I keep doing that. For noise and emissions, these are the two areas actually we have very strong portfolio in fundamental aeronautics program, and we have made a lot of progress in developing new concepts and also tools that will allow us to assess or develop new technologies.
Dr. Shin, if I may, because I only have a limited amount of time, I was present when Mr. Henne suggested that there was a large order of magnitude difference between our investment and the implication being our work in NASA in those areas as compared with Europe. Can you comment on whether there is this huge order of magnitude difference in either the quality of the work, the advancements achieved here in America versus in Europe?
I think recently it is a well-known fact that the European community is trying to increase the commitment in their funding in aeronautics research and development. So as Mr. Henne accurately pointed out, the funding is growing there.
But in terms of the technology, if you know, just to make a silly analogy, if they were still in the Stone Age playing with the wheel and figuring out what to do with that, they'd need a lot more investment to catch up to where we are. Where are they, though, in technology with regards to reduction in aircraft noise and aircraft emissions relative to where we are in the United States? And are they going to pull ahead of us in some dramatic and unacceptable fashion because of the relatively smaller amount of research dollars that are included in the President's budget for our country?
In short, my assessment is we are still far ahead of Europeans' capabilities and knowledge in addressing environmental impact. I do believe that. And Europeans have always copied, if you will, the goals and objectives that U.S. government agencies and also industry put out. So that is the one indication that Europeans are trying to catch up.
May I, Mr. Chairman, do I have time for two more questions? Mr. Henne, do you have a comment on that, Dr. Shin's last statement?
I would say from our assessment of products coming from Europe versus products in the U.S., they are very competitive. Our most recent engine selection was made selecting a Rolls-Royce engine that's actually made in Germany. And it's an excellent engine, very low noise. They are extremely sensitive to low emissions. The engine company recently made an unsolicited change in the combustor to reduce the emissions further. And
Dr. Shin, do you have any comment on Mr. Henne's last comment?
Yeah, I think the difference in my answer was I was talking about R&D capabilities, and I think Mr. Henne's answer was a current product line. So that was the difference in my answer.
But in terms of the way people live practically, the theoretical discussions of advancements in products are valuable, but if they never reach the product line, they won't help the quality of life as directly as those investments in product line research and development. When will this R&D in aircraft emissions and other emissions from aircraft that's being conducted by NASA bear the fruit of better products if, as Mr. Henne says, the products are now equal?
So your observation is valid, and the current U.S. technologies in noise and emission reduction started from 10, 20, 30 years ago from NASA's research. So NASA research has to put ourselves another 10, 20, 30 years ahead of current technologies, and that's what we are doing.
And with one final question, I wanted to ask about Dr. Shin, NASA's role in aeronautics research and development with regards to Nextgen, and ask the question if experts from the air traffic control community were consulted as this system has been developed. In other words, have actual air traffic controllers, the people in the towers who do this work every day, been involved in the development of this new air transportation system?
I would like to, if I may, I would like to defer that question to actually FAA because air traffic controllers and that association is not part of NASA. And FAA, my observation has been that JPDO and FAA have been working closely with Air Traffic Controllers Association and that workforce, but I am not part of that agency. So
No, I didn't ask about that. Is your answer then that NASA has not involved the air traffic controllers in its research?
We do heavily work with FAA and JPDO in air traffic management technology development.
I meant NASA directly with the air traffic controllers' expertise. Have you had that direct communication, or do you rely on whatever FAA tells you their conversations with the air traffic controllers have informed them of?
I apologize for not getting your question right away. We do work with air traffic controllers. In our research development, we do use air traffic controllers as observers, also participants in developing our technologies. So we do have that close relationship. But in terms of actual working relationship within FAA, we don't Right that way.
Good. 10 seconds. You've been so generous to me. I just want to make one comment to industry that, sorry, Charles, that I do believe industry has responsibility.
Mr. Rothman, why don't we do this? I will recognize the gentleman from Louisiana,
You're
Mr.
good.
Melanson, for 5 minutes, and he can do whatever he would like with the time.
Mr. Chairman, I'd like to yield my time to Mr. Roy.
Oh, you're so kind. Thank you. I just need a little bit. Thank you, Mr. Melanson. I just want to say I don't take industry off the hook in terms of its responsibilities to do its own research and development and pay for it itself. Can't rely on the government to pay for it all. And while I respect and appreciate the profit motive and the great work and the great products made by private industry, including great aircraft, you folks have some of that burden as well, and you can't simply say the feds are not picking up the whole tab, so woe is us, or woe are us. Thank you, Mr. Melanson, for yielding, and Mr. Chairman, again, for your generosity and your leadership, as always.
Thank you, Mr. Rothman. I would note that between the short time that Mr. Melanson yielded to you, the time you took, that you had 2 5-minute blocks, and you used them quite well. And as I speak on behalf of your constituents who admire and respect the passion and intensity which you bring the discussion to sound pollution, air pollution, and you have a very compelling case to make because when we get this right, not only your constituents but Americans all over the country will benefit from a higher quality of life because this is a problem that concerns all of us. I hear about it in my district as well. So thank you. And I thank the gentleman from Louisiana for being so generous as well with his. Let me turn back to the panel. The chairman recognizes himself for another 5 minutes. And Dr. Shin, I want to ask you what you consider to be the most promising areas of research in NASA's aviation safety program that could lead to new capabilities being in sort of the marketplace in the next 5 years, even the next 10 years.
Yes. As I mentioned in my testimony, we are enjoying the safest system, but we are also changing we will be changing a lot of things in air traffic management system and also introducing new vehicle concepts. So when you mix all those things, you don't know what kind of new safety challenges will be ahead of us. So from NASA research perspective, we are trying to be proactive and also forward-looking in utilizing the IT advancement in data mining and also analyzing and processing the data. So we are working with FAA closely to develop this aviation safety information and sharing system. So automatically we can analyze the data and identify the precursors before the accident actually happened. So that's one such area that we are working on. And also in the projected that highly automated system that we are all anticipating in Nextgen vision, software validation and verification is very important. So we have to work proactively to develop technologies that can ensure that all the software and automation are functioning as designed. So validation and verification is another challenge.
Anybody else on the panel care to comment?
If I could, Mr. Chairman, relative to safety, that's clearly a very high priority for our business. And I would like to point out one example of just excellent work by NASA that has led to a real-world improvement in aviation safety that is just now available, and that deals with synthetic vision. NASA has been doing synthetic vision work for years and years, and we some time ago did a joint program with NASA on a Gulfstream to look at synthetic vision. We flew it and learned things that were good, learned things that were bad. When we were done with that flight test experiment in conjunction with NASA work, we made a decision. It's time to go to market. Let's take it to market. It's now been certified. It's now going out in our product line, and it is a major advance in aircraft safety. And we're proud that NASA and we were joint together doing that to actually bring that to market in the end. So there's a lot of good things that the NASA generates, they're the source of. The trick is to get that technology developed all the way and take it to market. And that's one just great example of aviation safety that's now done. It's available.
Dr. Kroo, Mr. Meade, do you have any comments?
Just to look at the future area of aircraft safety, one of the academically interesting areas and an area that NASA is pursuing is the utilization of advances in autonomous systems and vehicle autonomy in general to both improve the safety of vehicles and to improve their the situational awareness of pilots. That also creates difficulty if, in fact, there are autonomous vehicles operating in the same airspace. NASA is addressing that problem to some extent. There's a lot more needed.
If I might, Dr. Shin, I'd like to turn back to NASA's handling of the NAOMS Aviation Survey Project. And as you all know, the committee's been concerned. We have a GAO review underway to look at the survey data. I understand, however, that NASA and the FAA are working on another aviation safety database activity. The acronym's ASIAS, I think ASIAS is maybe how it's pronounced, and it involves significant data mining and the merging of multiple disparate databases. As you know, the federal government doesn't have a great track record on the development of such large database management systems. What are NASA and yourselves doing to ensure that this latest effort stays on track and on budget? Furthermore, what are the specific objectives, budget, and timetable for the ASIAS project, and how are the responsibilities divided between the FAA and NASA? And you could respond for the record if you'd like. I know I just threw a lot of questions at you.
Yes, I just want to respond in real time about ASIAS, if I may, and the others, I'd like to provide more detailed information for the record with your permission. In the ASIAS, I think the real positive aspect there, sir, is the participants and who are actually playing together in this ASIAS effort. It is not just NASA. It is not just FAA in working in isolation. And it is not just airlines holding their information. So the beauty of this system is airlines are voluntarily providing their operational data, safety data, and FAA is in the lead role to make sure that all the confidentiality and all the other considerations are protected so that airlines can share their data. And NASA is providing the necessary technologies. So I go back to one of my earlier comments that the clearer each agency's roles are identified and understood, I think the better we will be off working together. So this ASIAS is one such case that FAA as a primarily regulatory agency providing the protection, and NASA as an R&D organization providing necessary technologies, and airlines do see the value, so they are coming to work together.
And let the record note that we say the acronym ASIAS, and
that's how I'll pronounce it.
And if you all do the job you want to do, I think it won't be a common parlance. It'll be an acronym that's only known to those who track these important efforts. But
yes.
Appreciate your explanation there. And if you want to add additional material for the record, the committee would welcome it. The chair recognizes the gentleman from Florida, Mr. Feeney, for 5 minutes.
Well, thank you. Dr. Shin, the NRC assessment indicated, among other things, that there are about 4 areas that have been established as a priority by the decadal studies that are getting no attention whatsoever and no work is going on. And I wondered what the other 3 were and why they're not a priority, but specifically with respect to the unmanned vehicles, it seems to me there would be some natural payoffs and that NASA would be the ideal place to study how we manage unmanned flight and how it relates to an increasingly crowded airspace. I know there are a number of federal agencies who have a keen interest in using unmanned vehicles, probably the private sector as well. And wanted to know why, what the reasons are that NASA has failed to establish a research project and make this a priority.
Yes, I would like to suggest that NASA current research portfolio does address UAV-related technologies. We do not have focused project bearing the UAV in the project name or title. So one might think that we are not addressing UAV-related technologies, but if we examine all the portfolio that we have, technology investment, a lot of technologies are contributing to the UAV community that they need in the future. So again, from the R&D perspective, we are contributing to UAV requirements and needs. In fact, I have asked, but this is a vague area because we don't have clear single project addressing UAV. I can certainly appreciate why external folks may feel that we're not addressing UAV as diligently or focused way as we should. So I have directed my program managers to come up with clear communication and cataloging all the things that the technology areas that are contributing to UAV. So that is in work. And when that documentation is completed, I would like to provide that to Congress for your information.
Well, thank you. And I can say that in addition to the technology, there's an issue about rules and protocols. The FAA, for a long time, hasn't really figured out how to manage UAVs, and that has been a hindrance, I think, in the private sector because they don't know when or if they're going to be able to get permission to fly. And that, so to the extent that regulatory hurdles and technology hurdles are holding back some real opportunities where we know we have needs. Mr. Meade, do you want to respond to Dr. Shin's?
Yes, sir, I can. The UAV issues with respect to the decadal study, remember that we have to match up the milestones that are specified in the decadal study with what NASA is doing. And if there is not an exact match, well then we basically have to say there's not a match. Notwithstanding the fact that NASA is flying a couple of Global Hawks very recently, I do believe, and some other unmanned vehicles, and so they are active in that area to help explain a little bit of the confusion. They simply did not match up with the milestone specified in the decadal study. So that's where that comes from. Furthermore, with regard to the large systems analysis that would be required to integrate a UAV into the airspace and fly it correctly, you know, NASA is very good at doing those sorts of things, but they're not the regulatory agency for deciding how to fly them in the airspace.
Are you, and you aware of the current status of the FAA's position as to giving permission or access to airspace for UAVs?
From the committee standpoint, no. From my own personal opinion, the last I heard, it was get above the controlled airspace, which is 60,000 feet, and fly it out. Obviously, that's a very specialized mission, and that's basically I'm uninformed in any other operations.
But obviously, that's having a real deterrent effect to development and use and experiments with UAVs.
Absolutely. If you don't know what the regulations are going to be, you can't design your system correctly.
Okay, thank you, Mr. Chairman.
I want to thank the ranking member for his participation today, and I think this has been an excellent hearing. We've covered a lot of ground with a really focused set of questions and testimony. I want to thank all of you for your presence here today. I would editorialize it. I think we've confirmed the importance of the aeronautics arm of NASA. I think we've confirmed the importance of it to our economy, particularly as we move forward. I think we've confirmed that we're in some strong competitive environments, Mr. Henny, but that we have the know-how and the capital and the potential if we have the right kind of support from NASA. And this is where I will editorialize. I don't think we have enough resources. I look forward to working with Mr. Feeney during the rest of this Congress and with the next administration, whoever leads it, to find additional resources for the very, very important work that's being done with NASA and in partnership with the private sector.
I wasn't going to say that I hope the next administrator is a former aviator, so I won't say that.
There would be an element of leverage there, wouldn't there? So, but I know whoever's the next president understands the importance of the new economy tied to aeronautics and I would add aerospace. If there's no objection, the record will remain open for additional statements from the members and for answers to any follow-up questions the subcommittee may ask of the witnesses. We've already received a statement for the record from Mr. Costello, who also serves as the chairman of the Transportation and Infrastructure Committee's Aviation Subcommittee. Without objection, so ordered. This hearing is now adjourned.
I'm glad you got
Is that right? Yeah.
Mr. Chairman.
Oh, no. That worked out perfect. No, I know how important this is to you. We can.
Very generous. I apologize if I took advantage.
No, we cannot ask good questions, important questions. And all back to that bottle of wine.
Hey, dividends. Look at that.
Yeah.
You get a little more time.
You'll spread it around, right? This is pretty cool. Do you see the stuff they've done? We want to do more of it. Yeah.